Hello and welcome to the second lesson in the representation of data unit. This one is all about binary numbers. Before we get on to what exactly that involves, a quick starter for you. Arrange these units in the correct order from smallest to largest. Megabyte, kilobyte, petabyte, terabyte and gigabyte. Okay, what order do you reckon they come in, smallest to largest? 30 seconds, off you go. Okay, hope you've done that. This is the order you should have got. Kilobyte, megabyte, gigabyte, terabyte, petabyte. Now, we didn't look at petabytes last week. I threw that one in as an extra one. But if you think about it, there's nowhere it could go other than after terabyte. It has to be bigger than terabyte because we know kilobyte is 1,000 bytes. We know megabyte is 1,000 kilobytes, gigabyte is 1,000 megabytes, terabyte is 1,000 gigabytes. There's nowhere else it could squeeze in. And it turns out it's 1,000 terabytes. It's the next one up. Okay, so last lesson, we learned all about bits. Bits are the fundamental unit of storage on a computer, and they represent off and on those tiny little transistors. Modern computers have billions of tiny bits to store their data, and we know that different combinations of all those billions of bits result in different data being stored. And over the next few lessons, we'll look at exactly how that happens. We'll look at how text, images, and sound all are stored as bits. But for this lesson, we're going to look at how numbers are represented as bits. Numbers are represented using the binary counting system. You've seen binary before back in year 7, but I'm going to go through it all again because it's been quite a while and it's really important we understand this. The rest of this unit is going to be very difficult if you don't get your head around binary. So binary is a counting system. There are loads of counting systems. The one we're most familiar with is called denary. That's how we count. The one that has 10 different digits. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That denary system is what we're used to. Binary is the same counting system but only using 2 digits, 0 and 1. Now that's perfect for a computer because it has bits which can only be off and on. So if we have a counting system using 0 and 1, then that's exactly what we need. Counting up in binary follows the same set of rules as counting up in denary. Now you've been counting in denary since you were about 3 or 4. You don't even think about how you do it anymore, you just do it. But the rules we follow are actually fairly straightforward and it's exactly the same rules that apply to binary. Let's have a look at how it works. We'll look at the rules first and I'll show you an example. Once you see the example, this will become a lot more straightforward. So first of all, we start with 0. Remember, there are things called leading zeros. The number 0003 is just the number 3. We just don't write those leading zeros. In binary, we do tend to write the leading zeros. So 0 we would normally write as 0000. And we start with that, and every time we want to increase to the next number up, every time we want to add 1, we check if we can increase the rightmost column, the units column. If we can, we increase it, and that's it done. If we can't, we reset that column to 0 and we move on to the next column and we try that one. And that's all there is to it. Let's look at an example and hopefully it'll seem quite clear. So we're going to start with 0000. Okay, and the first thing we do is we check the rightmost column, the units column, and we ask, can we increase it? Well, can we? Yes, we can. 0 can increase to 1. So we do just that. We increase that 0 to a 1. Everything else just stays the same. And there's our next binary number. It goes from 0000 to 0001, just like denary does. So let's increase it again. So same question. We look at the rightmost column and we ask, can we Can we increase it? Well, we can't in this case. If we increased 1, it would become 2. And there is no 2 in binary. There's only 0 and 1. So we've reached the maximum number for that column. It's as if we reached 9 in denary. There is no number above it in a single digit. So what we do is we reset that column. It goes all the way back to 0, and we move on to the next column, and we try and increase that. Can we increase the next column? Yes, we can. A 0 can increase to a 1, so that becomes 1. Everything else stays the same, and that's our next number. Let's keep going with that. So once again, look at this column. Can we increase it? Yes, we can. So that becomes a 1. Everything else stays the same. That's our next number. Do 2 more, and I'm going to get you to do a few. So let's look at this again. Can we increase this column? It's a 1, so no, we can't. So we have to reset it to 0 and move on to the next column. Can we increase this one? No, we can't. This is a 0 as well. So that also resets to 0, and we move on to the next column. Can we increase this one? Yes, we can. So that goes up to a 1. Everything else stays the same, and that's our next number. And then the next number, we check, can we increase this one? Yes, we can, so it becomes a 1. Everything else stays the same, and that's the next number. So those are the first 6 binary numbers. That top one actually represents 0. So that's 0, that's 1, that's 2, that's 3, that's 4, and that's 5. That's how we count using binary. So a task for you guys to attempt is this. In this table, I've done the 5 that we just did on the other page, and I've left some blank up the way to 15. 15 is the biggest number we can represent with 4 bits, with 4 binary digits, and that's 1111. So I want you to fill in the remainder of this table with what the binary would be. Start at 5 here, 0101, and follow those rules. Try to increase the rightmost digit. If you can, increase it and keep the rest the same. If you can't, reset it to 0, move on to the next digit, and then repeat. So I'll give you 2 minutes to try and do this. The video isn't going to pause for 2 minutes. It's up to you to pause it and then unpause it when you're done. I'll just disappear for a couple of seconds. Okay. Okay, hopefully you paused it. Hopefully you've filled all these in. Let's see how close you got. What you should have ended up with is this. All the ones in red are those numbers in the correct order. Hopefully that's what you got. Let's carry on. So we looked there at how we can count in binary, how we can keep adding 1 to the previous number to see the sequence binary appears in. Now that's quite useful for small numbers. It's not massively useful for big numbers. If, for example, we wanted to know what that number down there was, it says there it's 78, but if we wanted to figure that out, what we don't want to do is have to write out the first 78 binary numbers. That's going to take us forever. We want a quick way to be able to take that binary and turn it into that denary. Now luckily, it's really easy. In fact, I'd say it's even easier than the counting up that we've just done. So let's have a look at how it's done. We make use of the column values. Now you've been using column values since primary school in denary. We're used to seeing that number there, which is 5,273. The 3 is the number of units. There are 3 units. There are 7 tens. There are 2 hundreds, and there are 5 thousands. So in other words, it's 5 lots of 1,000, which is 5,000, plus 2 lots of 100, which is 200, plus 7 lots of 10, which is 70, plus 3 lots of 1, which is 3. Add them all together, 5,273. That's how our columns work. Now in binary, the columns don't go up in tens. They don't go with a factor of 10, so you don't times by 10 every time. You times by 2. So the first column is the units, same as it is in everything. But then the next column is the 2s, not 10s. The next column is the 4s, not hundreds. The next column is the 8s, because we're doubling the previous column every time. If this was a bigger number, the next column would be 16s, then 32s, then 64s, then 128s. So let's have a look at how we can make use of that to figure out what a binary number will be. So if I start with this one here, and we're going to convert that. The first thing we do is we write in the column headers. So I'm going to write in, in fact I'll do this with the computer, write in the column headers 1, 2, 4, 8, 16, 32, 64, 128. Each one doubles the one to the right of it. Now with those filled in, I'm going to look at which ones have a 1 below it, because this is telling us, for example, that there are 0 1s. Okay, so we don't care about 1s, there aren't any of them, but there is 1 2, and there is 1 4, and there is 1 8. There are no 16s, so anything with a 0 we can get rid of. So we highlight just the ones that have a 1 below, which is 64, 8, 4 and 2. We then add those all together, and that gives us the denary equivalent. So that binary number is 78, because 64 plus 8 plus 4 plus 2 is 78. So, task for you to have a go at here. This is hopefully fairly straightforward for you. In your books, I want you to try the following conversions. The first one's been done for you. So we wrote that out like this, put the column values in, then highlighted the ones that had a 1, which was just 4 and 1, added the 4 and 1 together, that gave us 5. Can you try it for the remaining 3, please? Once again, when I disappear, pause the video. Once you've done these, you can unpause it and I'll go through what the answers were. Okay, hopefully you didn't have too much trouble with that. These were the answers: 5, 51, 197 and 255. The only difficulty you should be finding in that is adding up. If you were to take this at GCSE, I'm pretty sure you'll have a calculator in the exam for this, so even that isn't particularly difficult. Okay, so that's converting to binary. Now, if you haven't got the hang of that, if you weren't sure how to do that, then you need to be on Teams, the second part of this lesson, asking for help. I can go through it in more detail, I can help you out with it, I can help you get your head around this. Don't just assume it's too difficult, you'll never get it. You can do this one. But if you've not got it at this stage, you need to be asking for help. The next bit is converting the other way, starting with a denary number and converting it to binary. So let's say we're given the denary number of 75 and we need to work out its binary representation. Well, there are 2 methods for doing this. I'll show you them both. You choose which one you're happiest with. We generally get about a 50-50 split of students that want to do one or want to do the other. That's fine. There's never been a requirement to learn any particular method. As long as you can get the correct binary value at the end, then it's a good enough one. So the first method I'll show you. This is a method I prefer because it's clear why it works. But the second one I think is easier to do, but it's not as clear why it works. And it's your preference which one you prefer. So the first method. So we said we wanted to get 75. So what we do is, first of all, we just write in the column headers. We just write those ready to add the 1s and 0s. So 1, 2, 4, 8, 16, 32, 64, 128. Okay, so with those column headers in, I then start looking at where I can get that 75 in place. Now for a small number, what we're trying to do really is just figure out which of these numbers we add together to make 75. Some of you who are very good at maths will probably be able to see straight away which numbers of those you add together to get 75, but I'm going to show you a formal way of getting there. So first of all, I'm going to look at the biggest number and ask, does that fit into 75? It doesn't. So there can't possibly be 128 in there. If I put a 1 under there, the number would be bigger than 128, and therefore it can't be 75. So that has to be 0. So 0 goes in there. Then I move on. 64. Is there a 64 in this number? Yes, there is, because 64 does fit into 75. So I'll put a 1 there. So now I've got 64 accounted for. There's 11 left. 75 take away 64 is 11. So I really should work that out. So if we put 75 take away 64 is 11. So now I'm trying to get 11 out of the remaining numbers. You can probably at this point look at that and go, oh, I can see that's 8 and 2 and 1. But I'm still going to carry on the formal way of doing it. So 32 does not fit into 11, so there's no 32s. 16 does not fit into 11, so there are no 16s. 8 does, so there is an 8 in there. So we take our 11, take away 8, leaving us with 3. There is no 4 in 3, there is a 2 and there is a 1. So that is our binary for 75. That's the first method. A lot of people very happy with that method, makes perfect sense. You can see what we're doing is we're just figuring out which of those column values we need to add together to make the number we're after. There is another method of doing it, which a lot of people really like. I'm not going to the maths of why this works, but if you do like it, you're more than welcome to use it. The second method for doing this involves repeatedly dividing by 2. Some people prefer this, it's probably a bit easier to do, but it's not as clear as to why it works, which some people don't like. You can choose whichever one of these two methods you prefer, it doesn't matter as long as you get the right answer. So to do this method, we start with the number we're trying to figure out, so 75, and we divide it by 2. Now that leaves us with 37 and 1 remainder. Now this is not decimal division. It comes to 37.5, but that 0.5 represents 1 that's left over. So in this one, if it comes to 37 and a half, that's 1 remainder. If it comes to 37 and nothing else, then it's no remainders. So then we take that 37 and we divide that by 2. That'll leave us with 18, also with a remainder because it comes to 18 and a half. Then we take that 18 and we divide that by 2, and that will leave us with 9, but this time no remainder, because 18 does evenly divide by 2 without leaving any decimals. We'll take that 9 and we'll divide that by 2, leaving us with 4 and 1 remainder. We'll take that 4, we'll divide by 2, which will leave us with 2 and no remainders. Take that 2, divide by 2 to leave us with 1 and no remainders. And finally we'll take that 1, divide by 2, leaving us with 0 and 1 remainder. So when that's done, you take your remainders and you read from the bottom upwards. That's the bit that people get confused by. You don't read from top down, you read bottom up. So first you take that 1, then you take that 0, then that 0, then that 1, 0, 1, 1, and that's the binary. That's the binary for 75. There's only 7 bits there, so we can add a leading 0 if we wanted to perfectly match the one we worked out previously, but that's our answer. It'll come to the same answer as the one we did previously. That's just another way of doing it. If you prefer that method, do that method. If you prefer the previous method, do the previous method. Either one is fine. So I want you to do a bit of practice on it. Remember, on the VLE, there's this video. There's also a PowerPoint which has an animation of this that you might find easier to follow if you're struggling with it. But to practice it, I'd like you to try these ones. Can you work out the binary for 18, 198, 253 and 100? Pause the video and disappear, play it again once you've done it, and then I'll go through the answers. Okay, so I'll do a couple of these properly just to make sure I've got the head around it, because this is a bit more difficult than the first one. So let's actually have a go at these ones. So 18, for this one, I'll do the second method, the dividing method. The next one, I'll do the other one, and we'll see where we end up with it. So we'll start with 18. We'll divide by 2 to get 9, remainder 0. Then we'll take 9, divide by 2 to get 4, remainder 1. 4 divided by 2 equals 2, remainder 0. 2 divided by 2 equals 1, remainder 0, and 1 divided by 2 equals 0, remainder 1. So reading from the bottom up, we get 1, 0, 0, 1, 0, and that's our binary for 18. Again, we can add in the leading zeros to get us up to 8 bits. So there's only 5 there. 6, 7, 8. So that's going to be the binary for 18. 198, I'll do it the other way. I'll start with putting in the column values. 1, 2, 4, 8, 16, 32, 64, 128. And we'll start from this end. Does 128 fit into 198? Yes, it does. So we'll put a 1 in there. We'll then work out what we need to make with the rest of the numbers. So we'll take that 128 off 198. And that will leave us with 70. So now we need to make 70 out of what's left. Does 64 fit into 70? Yes, it does. So we'll take 64 off the 70. That comes to 6. And I can look at this and see, well, the 6 is clearly made of 4 and 2. So I'll put those in there. And that's the binary for that one. Now, if you didn't manage to do these before and you now understand one of those two methods, I'm in the way for that one, aren't I? You understand one of those two methods, then by all means have another go at that one. But the answers to these were those. So if you did get that, well done. So that's all the skills I need you to learn for this particular lesson. Being able to count up in binary by adding 1 to the previous one, be able to take a binary number and convert it to decimal, and be able to take a decimal number and convert it to binary. It's quite a lot, but we have done all that back in year 7 before, so this isn't the first time through it. So your main task, your main assessed task for this lesson is just to complete the quiz on the VLE. It involves counting and converting both ways. Now, if you manage to complete that and you've got time left, which there's no guarantee you will, this was quite a lengthy lesson, then I want you to create a step-by-step guide for converting either from binary to denary or from denary to binary. The guide must be easy to follow and must help someone who's new to binary to convert a number. Okay, if you've done that, you can upload that to VLE as well. But that's an extension. If you've completed the quiz and you're out of time, that's fine. That's all I need you to do. This is for those that blasted through the quiz and now have time left over and need something to do. This is the thing. Okay. So well done, submit all the work you've got, and I'll see you for next week's lesson.